Hello learner, welcome again to Manifested e-learning platform. We are going to proceed ahead with a topic on three-dimensional geometry, and today we are going to look at geometric properties of solids. Geometric properties of solids. So in this lesson, our objective will be to get to know the properties of a triangle, a circle, a cone, and a parallelogram. So for a cone, many who doesn't know a cone, there's a representation of a cone here. That's a cone. Learners, a triangle, most are familiar with it. That is a triangle. In this case, it is an equilateral triangle. And there is a parallelogram. It looks like that. It looks like that. Two opposite sides parallel. Two opposite sides. The sides that are opposite are parallel. For a circle, many of you know the circle. So our lesson, so the objective at the end of the lesson, you should be able to state and identify the properties of a circle, a cone, and a parallelogram. So for a cone, I had earlier shown you. For a triangle, we have it. A parallelogram would look like that. So I told you when we are learning this, have an idea of having it in real life, where you can have a plain metal sheet or a piece of wood looking like that. So we have a triangle. In this case, I'll use an equilateral triangle. A triangle. The word tri coming from three, it means three, triangle, triangles. The second one is a circle. A circle. That is a circle. The third one is a cone. A cone. And the last one is a parallelogram. So those are the properties. We shall tackle the properties of these four. So we shall give this one A, B, C, D. So we shall start with properties of a triangle. So in our case here, I've used, we can use equilateral triangle. So if you have a triangle, you have it this way. I'm trying to use these because I'm able to pick it from the board. So when you learn, don't only have a mind that it is stuck on the wall. Think of a triangular sheet. Think of a triangular piece of wood. So straight to the properties. One of the properties of a triangle, as you see, it has 3 edges. It has 3 edges, which are for the sides. It has 1 face. So you will assume you are looking at it from this side only. So it has 1 face. It has 1 face. You can talk of it has also has 3. You can talk of this as the internal angles. 3 internal angles. It has 3 internal angles. So in our case, for that one, it was an equilateral triangle. So there is another thing we can look at, planes of symmetry. Planes of symmetry. A plane of symmetry will cut that figure or that object in 2 equal parts. So if I look at this, the triangle, if I look at the triangle, let's try and see. That is one plane. That can be another plane. If it is an equilateral triangle, and that one will be another plane. So there is another property that will come about. If I have that equilateral triangle, there are 3 planes that can cut it into 3 parts. So you can say 4 if it is an equilateral triangle it has 3 planes of symmetry. Planes of symmetry. An isosceles, if it is isosceles, it will have an isosceles will have 1 plane of symmetry. It will only have 1 because it will have 2 pairs equal. So if there is a line here, it will only cut each side into 2. Each side will be equal to that. If it is isosceles, it will have 1 plane of symmetry. One plane of symmetry. So if a figure has several planes of symmetry, sometimes the planes of symmetry intersect, and sometimes you can have an axial. You can have an axial of rotation. So if you can also write if equilateral, it will have 1 axial of rotation. It will have 1 axial of rotation. So it can rotate put there an axle, you can rotate clockwise or anti-clockwise. We shall then come to a circle B, a circle. So since we have a circle there, I won't draw it again. So straight to the point, it will have one edge. Most planes, depending on how it is, because since the edge of that circle, it's a circuit, it goes just to complete one edge. So one, it has one edge. Number two, it has one face. It has one face. It has one face. We look at its symmetry. The symmetry of a circle, face of symmetry, planes. You realize any diameter cuts the circle into two equal parts. So you realize in a circle, any diameter of the circle is its plane of symmetry. Any diameter of the circle is its plane of symmetry. So if I have this as the center, that will be a plane of symmetry. Another diameter there, a plane of symmetry. Those are planes of symmetry. And what do you realize? These meet at a particular place. Where the planes of symmetry meet, you can actually fix an axle. You can come out with an axle of rotation. So when you give the properties, there is, for a triangle, there is one property there which will be clear. The sum of angles add up to 180. Sum of angles add up to 180. So for 4, the circle has one axle of rotation at the center. It will have one axle of rotation at the center. It will have one axle of rotation at the center. We come to a cone, C. Properties of a cone. Number one, the cone is here. That was the cone. So we assume it is covered at its base. We assume we have the circular face and that. So where those two faces meet, will create one edge. So a cone, it has one edge. It has two faces. We have the curved face. Two faces. It has two faces. And there is something particular you'll notice about a cone. All cones will have a circular base. All cones will have that circular base. So you can find if you cut across, act as a diameter, you'll find it will cut that cone into two. So any line, any plane, you can talk of this as the apex of the cone. Any line, any face, plane cutting through the apex of the cone and the center of the base. Notice that the base is circular. Any plane cutting through the apex and that center, and you find there can be several. There can be several like that, the circle, and the base is its axis, is its plane of symmetry. Is its plane of symmetry, and you find that is where you can have the axle of rotation. It can rotate that way or that way. In a vertical, it can rotate that way. So a cone has one axle of rotation, one axle of rotation. It will have one axle of rotation. It will have one axle of rotation. Let's look at the last one, the parallelogram. The parallelogram, as the name goes, parallelogram. So for the triangle, there was another property there, that the sum of the internal angles will give 180. So it will be the same for solids. So properties of a parallelogram. One, it's here. One, it has 4 edges. 2, it has 4 edges and 1 face. It has 1 face. 3, the 2 opposite sides are equal and parallel. Are equal and parallel. Another property, the sum of these, the opposite, the sum of the internal angles is 180 degrees. You can also add another property. These opposite angles are equal. The opposite angles note that the opposite angles are equal. We move to another part, which is the plane of symmetry. plane of symmetry. You note that. Not for a parallelogram. Parallelogram. If you cut here, if you place there a mirror, that's a mirror. Let's see, will you get any particular plane of symmetry? Because the image of that has to come to the other side. The image should be at 90 degrees. So if you move here, we move to 90 degrees. It's likely to be somewhere there. So there is something you'll notice about a parallelogram. For a parallelogram, it's not likely to have any plane of symmetry, but I'll compare it with the rhombus. It's good to compare it with the rhombus. Since for a rhombus, all the sides are equal, whatever you see on that line, cutting it, whatever you see, the other side should be exactly the same thing you see on this other side. Whatever you see there should be exactly what you see on the other side. For a rhombus, it will have a particular plane of symmetry. So that's 1, 2. But for a parallelogram, note that for a rhombus, all the sides are equal. All sides. Note that for a rhombus, all the sides are equal. For a rhombus, all the sides are equal. For a rhombus, all the sides are equal. So a point here is the exact point there. A point here is the exact point there. So the plane of symmetry is like a mirror. But that's difficult to happen for a rhombus. So those are the properties for those given figures or solids. So having reached at that place, I think we've internalized the properties of each of the figures or the solids we've talked about. So for the assignment, so you'll answer the two questions, right? The properties of a circular cone, a triangle, and a parallelogram. Then how many planes of symmetry does a rhombus have? So having reached that, the objectivity of the lesson under the geometric properties of solids was for us to get the properties of those four solids. So at this point, we end the lesson, go through the properties before we meet next time. So have a good time and bye.